As mentioned before, the Taylor rule sets out a relationship between the Fed funds rate, the policy rate, which is implemented by the Federal Reserve, or the FOMC, Federal Open Market Committee, which is the rate setting committee based at the Federal Reserve, and then the inflation and growth gap. Taylor rule was originally proposed in 1993 by John B. Taylor. And one of the interesting things we can note is that when we actually estimate relationships between, in an ordinary least squares type framework, when we estimate the relationship between the Fed funds rate, the policy rate, and inflation and the growth gap, which I've demonstrated in previous videos, a kind of a reliable or a familiar type of set of values emerge for the coefficients. And so basically here I'm just going to run an OLS estimation of the Taylor rule and just demonstrate how that can be replicated then in RStudio. So more than that, but in Excel, what I have here is the Fed funds rate from the period that Alan Greenspan took over chairmanship of the FOMC until he finished up in 2006. So it's that data set for that period, and I'm just purely looking at the ordinary least squares relationship and the coefficients between these variables, and we include a constant in the regression. So if we use least squares, that can be obtained here using linest estimation, right? Now, if we want to replicate that in RStudio, might go into, or just open up the RStudio where I have some R script in the here that I took originally from Annie Kachova. Her website just sets out simple ordinary least square R script instructions. Okay, so we can have a look at these and then compare against our results in OLS. Now, one of the immediate things to note is that when you estimate a regression, you've got to open up a set of data. You have to incorporate into data, source data, right? And when you go switch from one computer to another, that the address is not always going to be the same. So we've got to, what we'll do here is we'll just delete the reference to the R drive and just specify the file, and then go into session here to set the working directory. Now, to have a look at the data in the Taylor rule green, it's a CSV file. CSV file is preferred normally for storing data because it's an efficient way of storing data, but we have data for Fed funds rate, for inflation, and for growth gap, again over the same period, 87 to 2006. So we're trying to capture the Greenspan period. Okay, so let's go back into our RStudio. Now, that file I have on my desktop conveniently, so if I want to, so there is a Taylor green CSV file on my desktop, and if I want to go to session then set the working directory, I can just neatly choose the desktop, and there's some files there for, I might just check that. Okay, so I'll just select that folder, desktop, and then I'll go to, so you can see here I have that Taylor green file open here, or available here on my desktop. Okay, so let's pull out of that then. Go back into RStudio, go to the session, set working directory, choose directory, and again I'm pinpointing the desktop, and then I come down and I just run, I can step through by just running the lines. Now we can see that as I step through there, attach my data, run, the data now is here. So we could have a look at that data if we wanted to. 75 observations, 4 variables. There's a date, there's a Fed funds rate, there's inflation and growth gap. So that looks okay. But just to be sure, we keep running. and we now call the Fed funds rate y, and x1 we're going to attach inflation values to this variable x1, or this vector or array, and x is going to be both columns of data, inflation and growth gap. And if we want to summarize y, then it's a summary of the Fed funds rate. We see it here. We want to get basic descriptive statistics of x, which is inflation and output gap. We have minimum, with median, with mean and maximum, and then the quartiles or percentiles. Okay, so let's some more basic statistics. Correlation between inflation, Fed funds, growth gap, Fed funds. The strong relationship between inflation and Fed funds, less strongly positive the relationship between growth gap or output gap and Fed funds. Okay, and we might expect that. And then we could do a little plot of inflation against Fed funds rate. We have it over here, and we can run, and we can do a single regression, single variable regression, and we get some output. So this intercept is the constant, and then if we regress using OLS, the inflation rate on Fed funds, there's this 1.38. Okay, let's run again, and we can plot that, and we can see a relationship between the two, and the constant and the slope of the inflation against Fed funds. Okay, so, and we can look at the fit, and then continue and plot that also. Okay, so most important for us then is the Taylor rule, and that's going to be a multiple regression where we regress the x vector, which includes inflation and output gap, on Fed funds rates. Okay, so we'll just step through this, and we get some output. And the output that we get here is we have an intercept of 0.01619, and on inflation it's 1.54, and on the growth gap 0.45. If we copied that, just copied, let's maybe copy more. If we copied that and went back into Excel where we were running this, okay, now I can take basically what we have here, it's the same. So if I just paste that in, these are the variables that I've directly copied over from Rstudio, and you can see the results I'm obtaining are the same as the results I obtained from the OLS regression set up in Excel. So using LinSt, I got these values. Using Rstudio or RScript, we get these variables, same standard errors, same, the t-values not automatically outputted here, but if you divide the coefficient by the standard error, you get the t-value. So 3158, same 8632, 8632, 028. Okay, same in each instance. And then we could look at the r squared 05099, and we have multiple r squared. Okay, so we can replicate results then in Rstudio, the results that we obtained here. Now something else I did, I took the model fit, where I took the estimated parameter coefficients, and then I multiplied and did a sum product to get the model fit. And then these variables I mapped against, so the green, the Fed funds fit, I mapped against the original actual Fed funds. That original actual Fed funds are these variables here for these dates. Okay, and one of the things we can observe is that in the earlier period, right, the green span seemed to respond much more aggressively. So Fed funds rates were higher typically than the fit. And then subsequently, again, that period 93, 94 onwards, the Fed responded more aggressively than the, let's say, the average type of responsiveness over the Greenspan period. But then very dramatically, from 2001 onwards, the FIT, the actual Fed funds rate, seemed to be much lower than the historic or the average responsiveness of Greenspan. So there was a change in behavior, and the big change occurred there 2000, coinciding probably with tech bubble collapse, the millennium bug, and then there was 9/11. And the Greenspan period, also the Bush administration, which was Republican. So Greenspan cut interest rates much more dramatically over this period. And then that led up to subsequently perhaps build up in asset price inflation in that period. So this period of aggressive rate cutting that we observe here, we might interpret this as being a contributor to the subsequent asset price bubble that we saw, particularly in housing markets, because interest rates, house prices, real estate, very sensitive to interest rates, given that a lot of housing property is acquired using debt. Okay,